Hey, good morning, good afternoon, or good evening, folks. Hope you're doing well today, and welcome to Unit 8. Brand new unit. Yay! We're starting today talking about forces. Here are the objectives for this unit. Please pause the video to take a minute to read over those. And we will be jumping into our first lesson, lesson 8.1, which is all about forces. So what is a force, you guys? A force is a push or a pull. So anytime you push open a door or lift up your book bag, which I know you haven't done lately, that counts as a force. Forces can transfer energy and momentum. We talked about momentum. We said momentum is a property of motion. A force can give an object momentum or can take away an object's momentum. And forces can cause an object to accelerate, which is something we'll talk about more in our next lesson. First thing to know about forces is that they are vectors, which means that forces have a direction. For that reason, we will often use arrows to represent forces. The size of the arrow represents the magnitude or the size of the force, and the direction that the arrow is pointing indicates the direction that the force is acting on the object. So for example, we have this rocket taking off. There are two major forces that are acting on the rocket. There's the rocket's weight, which is pulling downward towards the ground, and of course there's the thrust of the engines, which is pushing upward. And because the rocket is accelerating upward, we know that the thrust must be greater than the rocket's weight. Otherwise, the rocket would not be able to take off. This guy right here is Sir Isaac Newton, and he gives his name to the unit of force, which is a Newton. And when you write it out as a unit, you write it with a lowercase n, but when you abbreviate it with a capital N. Now, a pound is also a unit of force. When you talk about how many pounds you weigh, you're really talking about how much force you exert against the ground. 1 pound is equal to about 4.45 newtons. So if you know your weight in pounds and you want to figure out your weight in newtons, take that number and multiply by 4.45. So for example, if you weigh 115 pounds and you want to know your weight in newtons, would multiply 115 pounds by 4.45 newtons per pound, and the pounds will cancel out and leave only newtons. If you weigh 115 pounds, then your weight is roughly equal to 512 newtons. Now, forces can be either balanced or unbalanced. So let's start with balanced forces. When you have a book like this sitting on a table, the forces acting on that book are balanced. You've got the force of gravity that's pulling down, but then you have the force of the tabletop that's pushing up. And because the book isn't moving in either direction or is not accelerating in either direction, and that distinction is very important, then we would say that the forces acting on the book are balanced. Whenever the forces on an object are balanced, then they combine to act like there's no force at all. Now, sometimes it can be very easy to tell when the forces that are acting on an object are balanced. For example, if you have two equal forces, say 20 newtons each, and those forces are pulling exactly 180 degrees away from each other, then it's very easy to see that these two forces are balanced. The object in the center will act like it has no forces acting on it at all. In other cases, it's not as easy to determine if forces are balanced. In both of these situations, the forces are balanced. You'd have to set up some pretty complicated math to show that these forces are balanced, or you can just take my word on it. If all three of these forces, when they combine together, act like there's no force at all. So now let's talk about unbalanced forces. Unbalanced forces are when you have two forces acting on an object that do not cancel each other out. For example, in this first situation, we have this ball that's being pulled to the right by a force of 10 newtons. We'll call that positive. We'll say to the right is positive. And being pulled to the left by a force of 5 newtons. Now, those forces do not cancel each other out. So we would say that in this situation, there are unbalanced forces. Unbalanced forces can combine to produce a net force. And a net force is what you get when you combine all of the forces that are acting on an object at the same time. If the forces were balanced, then the net force would be 0. But if the forces are not balanced, then the net force is not going to be 0. For example, in this first situation, I have 5 newtons to the left, or negative 5 newtons, and 10 newtons to the right, or positive 10 newtons. If I add those together, Negative 5 plus positive 10 is equal to positive 5. So there is a net force of 5 newtons to the right. This object will act like it is being pulled by a single force of 5 newtons to the right. In this situation, we have negative 9 newtons, or 9 newtons to the left, and positive 6 newtons to the right. If we combine those two, then we're going to wind up with a net force of negative 3 newtons. So again, it will be like this object is being pulled by a single force of 3 newtons towards the left. The negative means towards the left. Now this is a little bit more complicated. We have one force of negative 8 newtons, which means to the left, and we have two forces of positive 5 and positive 7 newtons, which are pulling to the right. But again, we can just combine these three forces to find out what the net force would be. If we add the positive 5 and positive 7, that's positive 12. So the total force pulling to the right is 12 newtons. And then there's 8 newtons to the left. So when we add those together, we're going to wind up with a net force of 4 newtons to the right. We can also combine forces in more than one dimension. In other words, instead of just adding forces to the right and left, we can add forces to the north and south, or east and west. So let's take a look at each one of these situations and see if we can figure out the net force. Here we have 6 newtons to the east and 6 newtons to the west. Now hopefully you can see those two forces will cancel each other out. But then there's a force of 4 newtons to the north, which is not being canceled out by any force to the south. So the net force in this situation is 4 newtons to the north. Here we have 7 newtons to the north and 8 newtons to the south. There are no east-west forces. So this is simply a matter of combining these two forces. If we think of 7 newtons north as positive and 8 newtons south as negative, then we're going to wind up adding these together. We get negative 1, or 1 newton to the south. In this situation, we have 5 newtons north, but it is canceled out by a force of 5 newtons to the south. We have 7 newtons to the west, which is canceled out by 7 newtons to the east. All 4 of these forces are being canceled out by one of the other forces, so the net force in this situation is 0 newtons. These forces are balanced. Now this one looks real scary, but remember, it's just combining numbers. We have 7 newtons to the north and 9 newtons to the south. So when you combine those, that's 2 newtons to the south. And then to the east and west, we have 5 newtons and 5 newtons to the west. That's a total of 10 newtons to the west, and 8 newtons and 2 newtons to the east, which is a total of 10 newtons to the east. So the west and the east forces are going to cancel each other out. The forces to the east and west are balanced, but the forces to the north and south are not balanced. So we wind up with a net force of 2 newtons to the south. And that's going to be it for Lesson 8.1, Forces. I thank you very much for your time and attention. I hope you're having a great day and continuing to stay safe. Go on over to Google Classroom and check out the document that I'll upload as the assignment. It should be very short, shouldn't take you more than just a couple of minutes to finish up. I'd ask that you continue to stay safe, continue to look out for yourselves, keep washing your hands, and we'll see you tomorrow when we go into 8.2, which is all about Newton's laws of motion. Take care. Bye.